Today's lesson was about squares and cubes and square roots and cube roots, and this page is actually from period 7. So if it looks a little bit different from yours, if you're in 3 or 5, it's pretty much the same material. So we talked about the area of a square, and we have 3 is the side length of this square right here. And so that's a 3, and that's a 3. And the formula is side squared, or side times side. And so the area of this is 9 units squared. One of the things I noticed in one of the earlier classes is that 9 square units is not the same as 9 squared. It's 9 units squared. So the square is actually the label for the units. So if it says 9 square inches, that would be written as 9 inches squared, because we know that the area of this is 9, and if we write it as 9 squared, that's actually 81. So I just wanted to clarify that before you got into the word problems. The square root of a number is one of the 2 factors of the number. So this is what our square root symbol looks like. It's a radical sign. And here we have the square root of 25 is 5, because 5 times 5 is 25, and the square root is one of those factors, which is that 5 right here. The volume of a cube is s times s times s, which is s cubed. And it's cubed because volume is length times width times height, 3 dimensions. And so here we have 3 cubed, which is 3 times 3, which is 27 units cubed. Or in this case, it would be centimeters cubed. We also talked about the cube root of a number is written like this. That 3 that's right in here. All right, so that 3 right there, that's your index or your root. So this, down here, this box, it would say the cube root of 27. So that's the cube root of 27. The radical sign that we have right here, we don't write anything inside there. We don't write a 2, it's implied. It's implied that it's there. And then we also just did a little bit of vocab. This is 3 squared, it's a power. 2 is the exponent, and 3 is the base. We did our board activity where we went up to the board in groups. We did some practice with squaring numbers, finding the square root, finding the cube root, and then we came back and we consolidated our notes, and these are some of the examples that we came up with. So we talked about the square root of 9. We talked about the answer being positive or negative 3, because 3 times 3 is 9, but also negative 3 times negative 3 is 9. The 4th root of 16 would be plus or minus 2, but the cube root of 8 would just be 2, because negative 2 times negative 2 times negative 2 would give you negative 8. So one of the things that was mentioned is that if the root, or that index, is an odd number, then you're only going to have a positive solution. And then we all liked this one. 1 to the 5th power is 1. And the 9th root of 1 also is 1. I throw this one in here just for fun. 4 to the 0 power is 1. We talked about how you could have a problem like this, where you have a square and the side is like half an inch or half a foot, and how it still is a perfect square. So if you were to multiply the length and the width, 1/2 times 1/2 is 1/4. Well, what's the square root of 1/4? This is where here I actually broke it up, and I did the square root of 1 divided by the square root of 4. So you can see I took this problem and I just split it up. Square root of 1 is 1, square root of 4 is 2. So we just kind of proved that 1/4 is a perfect square. So then we came back over here. We had the square root of 4/9, broke it up into the square root of 4 divided by the square root of 9. and we got 2/3. And then we came down to this problem. I'm going to pause it and we'll be right back. Okay, so now down here we have the square root of 35. It's not a perfect square. So we can estimate which two positive integers it will be between by looking at the perfect squares that are one below and one above. So the square root of 35 is between the square root of 25 and the square root of 36. So we have the square root of 25 is 5, and the square root of 36 is 6. So this number, square root of 35, is somewhere between 5 and 6. Now here's where it gets really cool. We can look at getting our answer even closer by turning it into a fraction. So the first thing we're going to do is we have the square root of 25 is 5. So that's your whole number. We have to start with the lowest one because it's going to be 5 with some fraction, not 6. And then for the numerator, you're going to take the 35 from the original, which is down here, and subtract it from 25, and that's 10. And the denominator, you're going to take the high point of 36 and subtract it from 25, and that gives you 11. So the square root of 35 is 5 and 10/11ths. And you can check this on a calculator. I'm going to actually go to another page, and I'm going to do this one so it's a little bit bigger. So we have the square root of 71. So that is between the square root of 64 and the square root of 81. So we know that the answer is going to be between 8 and 9. So the first thing we have to do is we take the square root of 64, and that's 8. And now we have a fraction. So we're going to take 71 minus 64, and that's going to get us our numerator. So 64 plus 7 is 71. Now we need the denominator. We're taking this number, 81, and we're always subtracting the perfect square of that number, 8. So now we have 81 minus 64, which is 17. And the square root of 71 will be 8 and 7/17.